So this, how many different uniforms? This is actually a question that we could ask you. I probably have to give you a little bit more detail. Does the order matter when you put on your uniform as long as you put on everything? Well, I suppose you could argue you were talking about underwear, but if you're talking about helmet and pants and shirt or jersey and socks and shoes, no, the order doesn't matter. It's not like where you pick out a winner of a race, then the order matters. So this is a C question. Now I could do this with a, I'm going to actually decide we're going to just talk about helmet, jersey, pants, and shoes. We're skipping the socks just because we don't need that many choices. Okay, now how many different uniforms can we wear? Since the order doesn't matter, we've decided the order doesn't matter. We have one choice of helmet, one. We're going to choose one helmet, we're going to choose one jersey, one pair of pants, and one pair of shoes. It is actually possible that you could wear two jerseys at the same time. You might not even be able to see that you were wearing one under the other one, but let's just be normal and say one of each. Then you just have to ask yourself, look at this. This is some guy, really rich guy's closet. He leaves them that way, and then when he has to go to game day, he just takes them off the mannequin and puts them on. So how many choices does he have for a helmet? 1, 2, 3, 4, 5. He's got 5 different helmets he could wear. Now in the real world, I don't think this helmet here is legal, but it's probably an old helmet that they used to use way back in the day, kind of thing. But let's just say we have 5 choices of helmet. Do you get why it would be 5C1? How many jerseys? 5 different kinds of jerseys, 5 different kinds of pants, and shoes. Man, gotta look close. These are different. These are Nikes that have a white swoosh and Nikes that don't have a white swoosh. So those are all different kinds of shoes. So 5 shoes. And what do you do with choices? You times them. Now, couldn't you have done this so much easier? Yes. Because what is 5C1? It's 5. See, the only reason I did it is to show you can do it that way. If you needed to choose 2 jerseys, do you get, if I make it, oh, by the way, you can wear 2 jerseys at once, then it would be 5C2. You can't do that by just multiplying 5 times 5 times 5 times 5, okay? So you got to be ready for when the problems get more complicated. All right, another example like that, where what if the problem gets more complicated? All right, this time I'm doing a permutation. I'm telling you that up front. If it's a permutation, what do I know about the order? It matters. All right. The order matters. So I'll give you an example where the order matters. A race. You care if you're in first place. In the professional races, sometimes like the guy who wins NASCAR makes tons of money. In second place, not much. So yeah, they care a lot if they win. All right. So if this is a permutation, I can make it a really simple one. There's 30, let's see, 6 times 6 is 36. So there is 35 of you in this room right now. 35 students. And if we race across the parking lot and pick 2 places, first and second place, you get how that would be a permutation because we care about the order. I want you to now do it with blanks. We're just reviewing how you do permutations. Do it with blanks. Do you have to make 35 blanks? No, you're not checking on 35 places. You only care about 2 places. Now, blanks like this are choices. Valeria, how many choices do we have for somebody finishing first place? 35. And why can I not do another 35?
Because the first person already won the first place and I was only second place.
Yep. If you have got a choice for that spot, then they can't be in second place also. So must be 34 for that. Raise your hand if you got that one right. Cool. Do you get if you type this in a calculator or you type that in a calculator, you get the same thing? Okay. Now, what's better? I think blanks are better. Why? Because then I can say, do you get in the real world? We all might know that there's like an Olympic level track athlete in the room, and everybody knows Jim is like insanely fast. He's going to win. So then we could go, well, if Jim's going to win, we don't have 35 choices for the first spot. We'd have one choice for the first spot. Do you get what I'm saying? So you could do more complicated problems with this. Try doing that with this. You can't. You know what I mean? So the P is not very versatile. But the blanks, you can make all kinds of like, oh, but special conditions, this happens. And you only have one choice. All right, so let's do that. You've got 4 friends. You want to take out 3 of them and take a picture. But out of your 4 friends, you got a really tall friend. And you're going to put him in the middle every time because it'll make the picture look better with your really tall friend in the middle. Now, does the order matter? Yes. You care about where people are put in the picture. So, how many different ways can you do it? I just reviewed how to do permutations. I showed you 2 different ways. I told you which way was better. I'm going to say the problem one more time. You got 4 friends. You're pulling out 3 to take a picture. But you got a really tall friend. You're always going to put him in the middle in every picture. All right. Now you have, hopefully, 3 blanks and numbers in them. Don't even multiply them. Just talk to the kid next to you about what is in the middle and what are the other 2 numbers. Okay, stay with me. You were not with me. Get back with me now. All right.
So that'll be 2 and 1.
All right. If you start in the middle, Mr. Breen, well, there's only one choice because you had that really tall friend, so I put a 1 here. How do you think about it next?
There's only 3 other people you can choose for the first outer spot, and now there's only 2 people left.
And there you go. I bet almost everybody had 3 and then 1 and then 2. And he times them together, that's 6. In the real world, that means there's 6 different ways you could take that picture. All right. There were 4 people total. We said there's one guy that's going to be in every picture and he's going to be in the middle. So that meant there was only one choice for this. And that's why there's only 3 spots left, 3 kids left to pick for that spot and 2 for that spot. Okay, cool. Now, probability. Let's say your 4 friends are Jim, Sue, Kevin, and Sarah. And Jim's the really tall guy. Okay. This guy's tall. Now, what's the probability that it's going to be Kevin, Jim, Sue? Notice the difference? I said probability. You can say your answer as a fraction. Talk to the kid next to you. 1/6 is correct. Almost everybody's saying 1/6. There's only one way that you want, which is Kevin, then Jim, then Sue. And then there's 6 possible ways. So remember, it's what you want over what's possible. And that sets us up for today, where you're always going to have what you want on top, what's possible on the bottom, and here's how they're going to look. Everybody get to this page. They're going to have subgroups on the top and the total on the bottom, because this is all the possible things. And I'm going to put in parentheses totals. And you'll see why in a second. And the thing on the top is what you want again. What you want to happen. What you want out of what's possible. All right. I think it's going to work best if I show you this first one and you see how it goes. You're dealt 5 cards from a standard deck. And you think you should always, by the way, start on the bottom. You start here. So, if I'm dealt 5 cards from a standard deck, this is where it would be a totally unfair question. Because some of you don't know how many cards there are in a deck of cards. And so, you have a cultural disadvantage here, and that wouldn't be fair. So, we'd have to have a list of all the cards for a question like this. Okay? I did do that for you on the board. I left that, what the 52 cards are in the deck, and that'll be there in case we have a test question like that. We'll tell you. There's 52 in the deck, so let's put that here. Remember, that's the totals. And I'm choosing out how many cards. You might think that it's more complicated. You have to have some of these and some of these and some of these. I don't care about that. How many total am I picking out of the deck? 5. 52C5 goes on the bottom. Next, you have your subgroups. So they aren't all just cards. Some of them are hearts, some are spades, and then there's other things too. So this is hearts, and this is spades. But I know there's other things than hearts and spades, so I'm going to just put all of those together as a third C, and I'm going to call them not. They're not hearts and they're not spades. I could list them as what they are, which is diamonds and clubs, but I don't care about that. They're just not hearts and spades. So, how many hearts are there? Because that's where you put your like total possibles. If you know it, just say it, because some kids don't know cards. 13, good. And then how many spades are there? There's 13. And then how many not hearts and not spades are there? 26. Cool. We're almost done with this question. And then you just type it in the calculator. But we got to know, how many hearts do you want to choose? In this problem, how many hearts do you want to happen? 3. It says right here, 3 hearts. How many spades do you want to happen? 1 spade. And then 1 card that is not a heart or a spade. Ooh, that goes there. And now let me show you the most important thing for the hardest questions we give you on the test. These are the hardest ones that you get tested on. I mean, it took a while to set up. But honestly, you're going to like these because there's this cool way to check them. Because you can know you're right. If this and this and this add up to this, you know you're doing it right. And then also, if this and this and this add up to this, you know you're doing it right. So 13 plus 13 plus 26, that makes 52. You're going to have a calculator. You'll be able to check that. And 3 plus 1 plus 1, that adds up to 5. Now, if you just type this in the calculator from left to right, you're likely to not get the right answer because it's going to screw up the order of operations. So either get to the end and hit equals, or enter, and then divide by this, or put a parenthesis right there. If I were you, I'd probably just get all this done and get the decimal for that. It's like a big number. And then get this done and get the number for that, and then divide them. Either way, this is the part where we need to make sure you know how to type these in. This is as hard as they possibly get. Okay? Type that puppy in. See what you get from the top. See what you get from the bottom. Divide them. And you'll get a decimal answer. But please have the top answer separate from the bottom answer, so you can tell where you went wrong. Because you're gonna like compare to the kid next to you, and he's gonna have a different decimal, and you're gonna be like, well, I don't know, what did I do wrong? Then you can compare your top and bottom number, and then you'll know where you went wrong. If you both have the same decimal, you're probably right. Unless you made the same exact mistake. Okay, type this puppy in. How many of you done? Raise your hand if you're done. Okay, awesome. How many of you had the same answer as the kid next to you? Oh, seriously? Check. If you haven't checked, check. Because you get different answers, we got concern. 37, which would round out with 37. Oh wait, I'd round out with 37. Remember, your answers are going to be to 3 decimal places. Given that, do you get 0.037 to 3 decimal places? Raise your hand if you had 037. Nice. Okay. All right. These are difficult questions. They're not impossible. But let's talk about how you do them again. You start with the bottom and you put your totals down there. All the cards we had, all the cards we were taking out. On the top, we had the subgroups like hearts, spades, etc. All right, I want you to think about this in this room. We can do a question just like that in this room. You guys, there's not hearts and spades and stuff, but there's kids wearing sweatshirts and kids not wearing sweatshirts. Okay, you're one of those too. Okay, so raise your hand if you are wearing what you would consider to be a sweatshirt. You get to decide for yourself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 people with sweatshirts. You should already know where to put that. Next, I will tell you, I am certain, because I have double checked this, that there's 35 of you in here. You should know where to put that. There's one other number you can put. Because you know that there's 35 of you in here, which went here, and there's 11 with sweatshirts, I'm going to put SS for sweatshirt, and I'm going to put not for this. Then you can know by using logic that there must be a lot of people that are not wearing a sweatshirt, specifically 24, I think. Is that what you guys got? Okay, cool. Now, have I told you how many of you I'm going to select yet? No. But I'm going to just select you two. You didn't know I was going to pick them. I didn't know I was going to pick them. I picked these two. And did you call yourself a sweatshirt? Okay. All right. So we have one with a sweatshirt, one without a sweatshirt. What was the probability that was going to happen? I picked out how many people? 2. That was your total. And I got one with a sweatshirt and one with not. Does this add up? Caitlin, I told you how to check. What are you supposed to check to see if they add up?
If you add both numbers in, so 11 and 24.
11 and 24.
If they add up
Yep, and also,
This one equals 2.
there you go. And I think they do, don't they? All right. There you go. So now I kind of helped on those last two, but now you're supposed to be good enough at this to be able to do it yourself. So I'll give you another question about the 35 of you. Okay. Now there's a lot of people in here that are wearing shoes. I don't think there's any law that says that you have to wear shoes, but pretty much everybody does. But there's some of you that would say you're wearing white shoes, and some of you that are not wearing white shoes. Okay? So for today, you get to decide whether you call your shoes white or not. Raise your hand if you are wearing white shoes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 people wearing white shoes. All right. So far, you already have some of your answers. There's 35 kids total. How many with white shoes? 12? All right. Then you should know how many don't have white shoes. All right. I pick you and you. Did you guys both say you had white shoes? All right. I picked those two randomly. What was the probability I was going to pick two people that had white shoes? I'm going to put WS for white shoes and not. There was 35 of you. Totals always go on the bottom. And I only picked two people. The white shoes, there was 12. The not white shoes, there must have been 23, I think. 35 total, all right? Okay. And how many white shoes did I actually get? 2. How many not white shoes did I get? 0. Now, does this plus this equal this? It does. And does this plus this equal that? It does. Now, again, I don't want to guarantee you that if those add up that you're right. Okay? A kid showed me last hour a problem where she had a bunch of numbers that added up, but they weren't right. But if you know that each thing makes sense, like white shirts, did I really have, or shoes? Did I really have 12 people with white shoes? Yeah. Did I really take out 2? Yes, I did. Not white shoes, definitely has to be 23. And I didn't get any, so I got 0. And my totals were 35 people, and I chose out 2. Those all make sense to me. All right, cool. So then you just type it in, and at this point, I don't even want to because it takes too long. And if you can't type them in by now, you probably noticed that you're struggling with that, in which case you should ask me, and I'll tell you how to type it. If I were doing it, I'm pretty advanced at it, I would probably put parentheses here as I typed it in. And then I'd just be able to do it all at once and hit enter at the end. Okay, cool. Now, without any help, let's see if you got this. Remember I said start with the bottom. Okay. I hope you started with CC over C. And in this case, I think it's actually CCC over C. All right. And how would you know it's CCC over C? Because there's 3 subgroups. In the bottom, there's just marbles. And there's a total of 15 marbles. And I'm going to pick out how many. 6 marbles are selected. Who had 15C6 on the bottom? All right, you started right then. Okay, then I got red, I got blue, and I got yellow. And I got to ask myself, how many reds are there? There's 8. How many blues are there? There's 3. And how many yellows? There's 4. And do those actually add up to 15? And they do. So yay, I'm going to make all these numbers blue, and yay, they all add up. Cool. Now, Miss Carr, can you tell me how many red ones did you want to happen? 4. 4 are red. And 2 are blue. And that already adds up to 6. So what the heck am I going to do for this last number? 0. Because you want these all to add up. And then you just have to type it in and get the decimal. This time I would like you to do that because I want you to see, is my decimal answer exactly right? So take a second. Question? Okay, you want to come on up and is it the kind you can charge with a plug or? Okay, charge it right here. And you can put it in line and use it. All right, if you haven't already, please compare your decimal with the kid next to you. All right. Henry Ballard, what did you get? 0.042. A normal person on the street would probably say is a 4% chance that that would happen. But on your test, you can't change it to 2% because it'll actually specifically say answers must be decimals. Percents are not decimals. They're different. Okay, so 0.042. All right. This one, without any help. Remember the basics. Start with CC over C. Totals go on the bottom. And there's 2 subgroups. And in the top. These are always challenging. Don't even try to get the decimal answer at the end. You're just going to tell the kid next to you what you thought it was. What CC over what C? You need to struggle with this a little bit. It's like lifting weights. I can't lift the weights for you. All right, to guide your conversation, you start with the bottom. And I just want you to talk about your totals. What C what goes on the bottom? Talk to the kid next to you. All right, on the bottom, a lot of people say 75C4, and that is wrong. Because why? Because you aren't choosing only 4 of them. Aren't you pulling out 10 of them? 75C10. You're pulled out the first 10. You pulled out 10 of them, and you're going to now look and see how many defective ones did we get. So it's 75C10 on the bottom, not 75C4. All right, now the 2 subgroups. Is it like clubs and spades? Of course not. It's defective, which you should label, and then not defective. Defective and not. The better you label them, the better you'll do. All right, now you gotta ask, how many defective ones are there, and then how many are you gonna choose out of that? So how many defectives? The biggest number of defectives that I see is 4. Do you guys agree that there are 4 defective ones total? And then how many am I gonna pick out of those 4? 1. See, 1 is defective. All right, and then not defectives. Well, I can use logic and go, they never said how many not defective ones there were, but if there's 4 defective ones, there must have been 71 that were not defective. And I want 9 of them to be chosen out of 10. Then the last thing you do, did you check that and that makes that? And that this and this makes this? If you check that and they did work out, they added up, then you can know, not that it's a guarantee you're right, but that you're very likely that you did it right. All right. Do you have any questions? How many of you did it right? Raise your hand if you did. All right, that's amazing. Normally on these problems, we a ton of people get them wrong. We're going to do one more because defective problems are so hard for people. Just do one more. Okay. Don't get the final answer as a decimal, that takes too long. But tell what CC over C you have. Talk to the kid next to you about your CC over C.
I did that, but I started.
All right. The biggest totals, I go on the bottom, and that's 120. And then that'd be a common mistake right there. Because I didn't actually select out only 3. I take 5 printers out. That's bigger than 3. I took out 5 of them, and then there's defective and not. And then how many defective ones are there? 3 are defective. 3 of them are defective. And now, how many not defective ones would there be? 117, because that makes a total of 120. And then defective ones that I actually get, the thing I want goes on the top. I want to get 1 defective one and 4 not defective ones. 1 and 4 makes 5. 3 and 117 makes 120. You feel like you're getting this? All right, if not, you can always walk up and ask for help. And this is the part where we get to the homework, which is a Schoology quiz. I have set it to 2 tries because I feel like this is really important because the hardest questions on the test are like this. I'm making it worth 10 points on the homework, which is double the normal homework assignment. So do this one well. Remember that after your first one, you normally could go check the key, but you can't this time. So I want to have you try your first one, write it on paper. Don't type it in the answer key until you see what it is, because we're going to do it together on the board. So it's a CC over C, and I got it started up here. And see if you get the same thing as me for the first one. You can type it in as soon as we verify it as a class that you're doing it right. Max, you already got it? Okay. Well, you know it starts with 8C2, and that's for juniors. There's 14C5 because there's 14 total kids, and we're picking out 5 of them. And the seniors is the only thing I left for you. Jaron, how many seniors are there in the question?
There are 16 years.
All right, so I'm putting a 6 right here. And that actually makes sense because 8 and 6 makes 14. For those following along at home, we have 8C2 for the juniors and 6 seniors. I haven't finished it yet, but there is 14, and I'm choosing out 5. And then what's the last number? I can use logic. This and this, somewhere it must say that there's 3 seniors, right? If it doesn't say, I can assume if there aren't juniors, they must be seniors, and so there has to be a 3 there because these need to add up to 5. Please divide those and get a decimal, and I'll tell you if it's right. How many of you already have the decimal? I don't want to make you wait too long. All right. Did anybody else get 0.28? Nice. Now, I totally understand if you put 0.280, but obviously that 0 is not necessary. So, all right. That's how we start. Now you got a bunch of time. You're going to have to switch to permutations in a minute. Remember when order matters? Then use blanks. That's the safest way to do a permutation problem. Because that way if they have like, but the first person has to be Jim, then you like only one choice for that, you know? So use blanks when you hit the permutation questions. Sometimes you can do them with a P, but... All right, that's all I got for you for today.